Hello,
Hello, sir.
I'm audible to you.
Yes, sir.
Uh, I just share my screen first. Is there any problem with the Google document or
Sir,
you
I
can?
just now installed the latest version. So I tried today and then I let you know tomorrow, sir.
Oh, okay.
Yes. Because its installation take more time. It's 2023 crack version.
Yes.
Yes.
It will take more time.
Yes.
You are installing full version complete.
Uh, yes, I think I need to verify. I just now its installation finished.
Okay. You just have you selected all the components while
Yes,
installing
I select just it's
the
a
default
default
one?
one only. Yes.
Okay. So my screen is visible to you.
Yes, I'm now sharing.
Is it visible
Yes, sir.
now?
LabVIEW 2021.
Yes. Today I show you the board that is my Rio. That is a educational board. It is having the capability of FPG also. I just show you how to program this. Before this, we just go with the waveforms. So I just create a new waveform, a new VI. Over here, as you see in the in this part in the graph, we have a mixed signal graph. You can use digital waveform already done. Today
Yes.
we just go with the mixed signal graph first. So over here I just drag and drop to plot the waveform. I just need a sine wave function. I just go to the signal processing. Over here, waveform generation. These are the basic waveforms available in the NI. So I just go with the sine waveform. I just drag and drop. This is my sine wave. So it will generate sine wave function. Okay. So over here, I just go to the cluster. I want to bundle this signal, and before this I just need a absolute value also. First I just plot a analog signal, then I convert it to a digital signal, and I just plot all the analog and digital in the same graph.
Okay.
Okay, so I just make it absolute over here. So this second signal is my absolute one, and first signal is my exact sine wave. So I just connect this signal over here. So let's run it. As you see over here, the white one is my sine wave. First one, this is my sine wave, and second one is my absolute signal,
Okay.
because when negative is there, it just make it absolute. Over here it is my positive signal. And if you want to just add on, you just select the mixed signal graph, add plot area. It is very useful and very user friendly graph. So I just add one plot over here, as you see. So now if you want to just make or put this signal from here to here, you just drag this like this. As you see right
Yes.
now, above one is my sine, and below I have this one, my absolute one. So this is my analog signal. Right now I just go with the, I want to just convert this analog signal into digital signal. So for that purpose, I just go to the waveform. Over here, this is get waveform components. Just connect it to the sine function. Over here, I just got the different signals. Now I just need to convert this signal. So I just go to the comparison, and over here, when this value is equal to 0 or greater than 0, this one, when this value is greater than 0, it will generate true or false, okay, according to the function. So when this value over here, it will generate true function, otherwise 0. For the negative one, it will generate false function. So over here I have the signal. Then I just go to the build array function, and I also want to I also just negate this value also. I just plot two values in this case. So over here, this is my original signal, and second one is my opposite signal or negate signal. So this is my append array. So over here, you just need to convert this signal. You just need to transpose this signal first, because over here I just got the value in the column wise. So I just go over here. As you see, this is my transpose 2D array. I just connect this one. It will transpose my signal. I just show you when I just remove this transpose signal, what happened to the signal in the waveform graph. Now I just go to the digital waveform, and over here I want to convert. So over here in the digital waveform, this is a conversion chart. So over here, Boolean array to digital, binary to digital, string to digital, there are different functions available. So right now I am just using Boolean array to digital function. It will convert this Boolean value, because as you see over here, this is a green value. So when over here we have the scalar value that is in floating value, like 2.0, not 2, it is because it is between 1 and -1, sine wave is between 1 and -1, it will generate. So over here I got the value in floating value. Then according to the comparator, I just got the value true and false only. So over here we have Boolean values. Now I just convert this value into the digital waveform, and this digital waveform goes to my bundle function. So over here I just connect it. So now I just run it. As you see over here, this is line 0, and this is line 1. This is my original signal, and this is my negate signal, opposite signal, you can say, okay. And over here I got these two signals, and if you want to just again add plot area over here, and you just move this signal to the particular this graph. If you want to just move, you just select the signal and just drag over here. You just separate these two signals in the graph also. No need to convert from here in the programming part, okay. This is the advantage of this mixed graph. So now if you want to just, as you see over here in the signal processing, we have waveform generation, we have only sine wave. Let's say we want to go with cos wave. Over here, as you see, cos wave is not there. So in that case, we just convert this sine wave into cos wave. As we know, sine is my 1 minus sine, cos is my 1 minus sine square root. It will give me the cos wave. So for that purpose, I just create. So first I just multiply this sine signal. So it will give me sine square. I just subtract this value from 1. This value is subtracted from 1, and I just need square root of this. Okay, so over here I got the cos signal according to the formula. As we know,
Yes.
cos is my 1 minus sine square root whole square root. So I again just copy this function, convert this signal, and again I just go with the comparison chart, connect it. And if you want the digital signal of this one, you just copy this complete function. Otherwise, if you want to just plot this function, just drag this bundle function and over here connect this. It will generate only absolute value, because as you see over here I am just squaring the sine value. When we go with square, it will only generate positive values over here. As you see right now, I just show you. So this is my waveform 3. I just drag this over here. As you see right now, sine wave is this one and it is generating cos wave. Okay, only one half, not the negative half. Negative half is not there in this case. Okay, so this is how you can use your mixed signal graph for creating waveform. In this, you just plot analog values as well as digital values. Okay, so it is up to you. So this is about the mixed signal graph. Another one, if you have digital data with you, you just want to plot that digital data and convert or compress that digital data. I just show you how you just do that function in the LabVIEW. So first I just search over here about the digital data. So you just go from here, this is my digital data. Otherwise, directly if you just go to the palette, control palette, in the input output over here you just check digital data. Okay, you just drag this one. So over here you just write your data. It is originally in hexadecimal form. Right now I just put it in octal form. Let's say 010, second 110, 110, 011, 011, 111. Let's say this is my data. Okay, I just make it 1 also. So in this case I have total 13 data from 0 to 12. Okay, so now I just want to compress this data. So you just go to the waveform, digital waveform, and over here as you see there are different functions related to the waveform. Get digital waveform components, build waveform, we already did that. Right now I just compress this data. So I just use this block, connect this function, and I just minimize this. So I just copy this again over here. This is my input and over here this is my output. I just need to change the behavior of this, change it to indicator. As you see right now, just connect this function to the output function. When I hit on run button, it will compress my data. So I just run it. As you see, it will compress my data. The compression is based on as you see 0 1 0 1 1 1 1 1 0 and 1 1 0 data is repeated, so it
Yes.
will just take it only one time. First one is taken over here, as you see 0 1 1 0 1 1, 3 is over here, 4 is not there after compression. Okay, if you just go with the again waveform, digital waveform, uncompress the data over here, I just connect the waveform over here, not over here. So just check the data is available with me or not, or the data is deleted. So again I just copy this, output 2 will contain the same data originally we have. So when I again run it, as you see the data is
Yes.
available with me. Okay, so this is how you can work with digital waveform. So there are different palettes, as you see in the LabVIEW. It is not possible for a trainer or any teacher to complete all the functions, because
Yes.
LabVIEW is very vast. Okay,
Yes.
so we just go with different functions. Likewise, as I told you, the digital function right now it is a in the form of octal I am using. If you just want to plot this function in the mixed signal graph, or you just need to plot this function in the graph, let's say. So let's say I just want to plot it in digital waveform. So over here when I just connect it and run it, so as you see over here it is plotting like this. Over here this is my first column, this is my second column, this is my third column. So 0 is my line 0, this one line 0 over here, as you see 0 0 0 for 3 values, 0 0 0 is for 3 values. After that 1 1 1 4 times, 1 1 1 4 times. And if you want to just more clarity over it, I just make it like this. So from here it is more clear to you. 0 0 0 is there. Okay, and in the second line means line 1, as you see over here, the middle one is all the ones are there, as you see all the ones are there. And when there is value, there is no value inside this, the default continue, the last value continue till end. As you see the last value over the 12 is 111, so in the all the values it is continuing to 111. So like this you can plot your data, you can compress your data or uncompress your data. So now I just go with the XY graph, the next case related to the graph, that is XY graph over here. For this you just need two types of data, one for x-axis, one for y-axis. Okay, so let's say I just create a array over here, blank array, and in this blank array, so over here this is my x-axis, let's say. I just copy this one, this is my y-axis, let's say. So over here let's say the values 1 4 8 8 7 9 10, and over here value is let's say 2 25 35. It is up to me what values I just put inside this 12. So these are my two values. Now I just need to bundle these functions. And I just connect this. As you see right now data
Yes.
mismatching is there.
Yes.
Right now data mismatching is there, so you need to just convert this data to the dynamic. So just go to the express function, signal manipulation, from convert dynamic data, convert to dynamic data. Let's just check it. So my data is one dimensional array, two dimensional array in this case. Just connect over here, delete this one, connect this one. Right now it is again showing issue. Have you heard about this dynamic data?
No, sir. First time doing.
Okay, so I just show you what is over here in the signal manipulation. Like if you want to merge many signals, like over here we have merge signal,
Yes.
likewise we have split signal. It is basically just work like build function that is available in array.
Yes.
And over here we have two types of signal, from dynamic data to dynamic data. Okay, so when
Okay.
I just place over here, as you see there are different types of data we have in general. We with in our life, like one dimensional array of waveform, one dimensional array of scalar automatic. So according to your application you just select the data type first, and it will convert your data, convert from dynamic
Dynamic.
data to the particular one which you want in this case. Okay, so I just close this one. And same way we have in the express this one, two dynamic data, convert to dynamic data. Initially we have scalar data, we just convert to the dynamic data. Okay, so I just remove this one, control B. Let's check what happened. The type of source is two dimensional array of double, and type of sink is one dimensional array. Let's just first connect only one value. Type of source is one dimensional array, type of sink is one dimensional array of two cluster. Okay, I just need to bundle this function. Let's check. Let's do it, run it. As you see, we just got the XY graph for this. If you want Lagrange's pattern, in this case I just remove this one. In place of this function I just use a for loop. Over here it will give me the iteration from 0 to 1, 0 to up to values, let's say 10 values I want. And in the second case I just make a formula over here. Let's say I want to multiply all these values. It will give me, so the base, this one is my one signal, this is my second signal, and inside this I just connect this XY graph. It need array, so that's why I just connect over here, run it. As you see, the values exponential graph is there, and if I just make it 100, for the circle I just need to put the same values inside the array. Starting point In the case of for the Lizash's pattern, we just need the data. In the next lecture, I just show you how to plot the Lizash's pattern. Okay.
Okay, sir.
So for today, it is clear to you why it is not connected inside the loop. Is there any issue? As you see right now, I am just connecting over here, because in the case of graph, when you go with the graph, any graph, it
Okay.
needs a array, and in this
Yeah.
case, as you see over here, I have the scalar value. This is my integer type value. I just over here again, this is again scalar value. Over here I just make it cluster type just, and over here I just output cluster, and it is not connected to this one, because over here again it is generating a scalar value. So in the case of graph, you just need set of values. As you see over here, it is auto indexed, all the values auto indexed, and when I just connect this one over here, it is just creating array over here, and I just, and this xy graph is connected. If you want to just go with the chart is connected over here. I just show you. If you just go with the chart, as you see over here, this is my chart, and when I just connect this one, there is no issue with the chart, because it needs only single value. In the case of chart, when single value comes, it will just plot it, but in the case of graph, it needs a set of values. Okay, so that's why this is the issue. In this case, when chart is there, as you see over here, exponential graph is there, because one is every time I just squaring the values, and second value is my below over here, as you see. And when I just plot it for only 10 values, it will clear to you. As you see, different values are there. 9981. Some issue is there. 1 minute. Because in the case of chart, it is storing the values. Okay, so when I again hit on run button, as you see, the total values inside this graph is 100 plus again 10, total 0 to 109 values are there. If you just make it clear, first clear the chart, when you hit on again run button, it will show you the values. So 0 to 10,
0 to 10.
it goes to 0 to 10, and over here 10 into 10, not 10, 9 into 9, it is 81. Okay. So this is how you go with these graphs. For Lizash's pattern, I just select the values first, then I just show you how to go with different values, or how to plot circle or different Lizash's pattern inside the XY graph. In the next lecture, I will show you.
Okay.
So today I show you the MyRio. If I just give you an assignment, like earlier we just go with different signals using MyDAC. 1 minute, I just open the camera first. In the previous case, we just go with only single data acquisition, like we just acquire the signal, we just generate the signal, we just acquire multiple signal, we just generate multiple signal. If you just want to first acquire the signal, and according to that signal, according to the condition that is given by you, you just need to generate a signal. Can you create any case for that? How to go with that signal? Like I have a sensor, let's say earlier we go with, in the last lecture we go with the IR sensor. When I just place my hand in the front of IR sensor, it will generate around 3.2 volt or 3.6 volt. Okay, so according to that signal, I want to generate a particular value from another pin. If you want to, Yes, if you want to go with that signal, that type of signal, in that case I just show you. So first I just show you the program. Okay,
Okay, sir.
have you take the this deck card from your company?
Sir, they are using for communication NA8451, sir. Not they are using any, because they are saying it's already installed on the LabVIEW system, but I am not verified.
Okay, in your company the product name is 8254.
8451, sir. That is the communication one. 8451.
8451 NI
NA.
from
Yes.
NI.
Yes, sir. It is the communication device.
Okay, okay. I just go
And-
through this and have you any information about this deck card? How to use this one?
This one, the 8451 or
8451.
8451 we are using for the I2C communication purpose, sir.
Okay.
The SPL, SDS signal, the high low, and then RxTX communications.
This one.
Yes,
It is
sir.
similar to our NI USB 6008. Nearly similar
Yeah,
to.
the pin diagram is almost similar, but the working principle is
Yes,
different.
yes. Working principle is different because internal architecture is different.
Yes.
Okay. So using this card, what type of signal you acquire?
Actually, we are getting the signal from our power supply, SCL data, and then we are communication is for high and low. It is for the CAN communication. It is high, low, up 0 and 3.6 something voltage.
Okay. Mainly you just read analog signal.
Digital signals.
Uh,
It is the microcontroller signal. It is mainly for digital.
because let's I'm just reading your application. Let's say this is my deck card. Okay, this is
Yes.
your, let's say, 8451.
Okay.
Before it, you just place another microcontroller.
In the power supply, we have one microcontroller, the internal one.
Okay.
So
And
we are
that
reading the
microcontroller
data
sending signals to this device.
to this one, yeah, and then we on our output is we are capturing to using for the instrument.
Okay.
For example, the AT is the right. Previously I told, right, Chroma 8000.
Okay.
AT is of.
So mainly you are acquiring digital signal only.
Yes, sir.
But the microcontroller reading analog signal.
Yeah, micro reading analog, and then the output is digital.
Okay. Okay. So you need help with which device?
Actually, this one work is a 8451. We already have the data, then I can modify. I need to configure one thermal chamber, sir.
Which one? Again, please tell me.
I need to configure one thermal chamber.
Thermal chamber.
Yeah.
Okay. So in that case,
they
you
are
just
giving
need
option
to.
for, yeah, they are giving option for using LabVIEW or Python script.
Okay.
So Python script I tried, I cannot get the configure from the instrument. So we are asking the driver for the thermal chamber, but I am not sure when they are getting. If they are provided, then how can I configure the thermal chamber? You have any idea?
For the thermal chamber, first you just need the let's say this is my this room is, again, let's say this is a thermal chamber. Let's check. Say
Yes.
For this thermal chamber, first you need a data sheet.
I sent the data for you, sir, the thermal chamber name and the link I sent to your WhatsApp.
Okay, I just go through this after the lecture. Okay.
Okay.
So I just go through this, how to configure this lecture, because in every case, every device, let's say this is a chamber or any device, in this you just need to control the first read the temperature, and after this you just need to control the temperature of this chamber. This is maybe this is the application you want.
Yes.
Okay,
Read
so
and then changing the yeah, correct, the temperature adjustment.
or
Yes.
and the for the temperature control, for the temperature controlling, we just need two devices. One is one heating device that will generate temperature, and another one is cooling device, that is my AC, that air conditioner. So according to these two, according to the condition, we just need to on off these two devices mainly, and when the temperature reached, we just close the device. So maybe this is the case with you. So I just explain you the example with for this particular temperature control. I just go through this 8451 also. It is having analog or digital signal acquisition or not. So I just create a VI also for you. For example, how to go with chamber. I just make a virtual chamber in the VI. I just go through
Okay.
these examples first. So today I just first create in this example also, as you already told me, in this case you just first acquire the data, and according to the data or according to your condition, you have to maintain the chamber temperature. Okay,
Yes.
so I just explain you how to create a condition for this. Let's say through the DAC device, I just connect my temperature sensor to one input,
Okay.
any analog input you just connect. Okay, so in this version I don't have this DAC device. I just go to the LabVIEW 2023 version. So I just show you the example when you just getting the data. After getting the data, how to apply different condition in between before generating the data. Okay, hello.
Yes, sir.
So over here, this is my VI LabVIEW 2023, and I just show you that using DAC Max, not using Express VI. I just show you the Express VI also. So right
Yes.
now my DAC device is connected to my PC. When this DAC device is connected, or any DAC device is connected to the PC, this LED goes on. If it is having any LED. Okay, so right now it is connected. So I just create first for reading the data. So as you see, first analog, start the task, then I want to read, then I want to stop, and after that I just you just make clear also in between. It is up to you. Right now I am not using
Yes.
clear function. Just connect error into error out, and over here you just need to set the physical channel, create constant for it, and in this I just set AI 0, let's say. So it will generate, it will acquire signal for me. Let's say temperature pin, any temperature sensor, let's say LM35 or any thermocouple is connected to this AI pin, analog input 0 pin. Okay, let's say. So it is generating values from here. So over here I just got the data of temperature. So I just connect this thermometer, let's say, for display. So over here I just got the temperature data, and the temperature data is in the form of voltage, because every device when we just deal with temperature, any flow, any pressure, we just, when we just want to read this signal, it is in the form of voltage or current. and maximum time it is in the form of voltage. Maybe it is more clear to you as you are working on different hardware devices.
Yes.
So right now, as you see over here, my temperature is there when thermocouple is connected to AI0. Okay, so over here this is my temperature, and I just want to maintain the temperature between some value. Let's say
Yes,
we already gone through the VI also.
yes.
Okay, so you just need to set the value. Let's say when the value and in this case also, because over here you just need to generate the signal also. So for that purpose, I just again copy this one, place over here, and in this place I just remove this one. I remove this one. Over here I just need, if you want to just generate signal, it may be analog output or it may be a digital output. Okay, right now I just set digital output. So over here you just need to set the line, because in the case of AC on off or in the case of heater on off, you just need a signal on or off. It is 0 or 1. It is up to you. Okay, so I just create constant over here, and right now I am just using digital pin 0, port 0. Let's say it is my output pin. So over here I just go to the measurement again, and in this case I am writing the task. Over here you just need to set the pin boolean line 1. So this type of task you just need to set. Let's say when the temperature of the room or the chamber is above the 25 degrees Celsius. Okay, so in that case you just need to switch on the heater, not a heater, AC. In that
Cooler,
condition, you just need to cooler or AC, it is up to you. So for that condition you just go over here. When the device temperature, the temperature comes from here, the device temperature is greater than some specific value that is decided by me, it will generate a true function. Okay, and this signal, true signal, goes to over here, and this signal goes to your pin, output pin of digital pin, and this pin is connected to this digital pin AI0, and this pin is connected to the relay. You are aware with relay?
Yes, sir.
Okay, so it will turn on a signal. I have also a relay. I just show you the basic relay in the projects, BTech projects, the students. So as you see over here, this is my relay module.
Yes, sir. Relay.
Again, it has 3 signal. One is VCC, one is ground, and one is signal. What it is on or off. Okay, and on the other side, we just connect our AC. Our not in this case. In this case, because the capability of this relay is not for the AC. It will run for any fan, any light. For the higher capability, we just replace this relay with the higher one. Okay, so in this case it will generate signal for this relay when the temperature automatically, according to my condition, when the temperature goes over 25 degrees Celsius. Okay, so it will generate a true signal from here, and this true signal goes to the DAC card, and DAC card will generate a signal for this relay, and this relay turn on your AC in this case. Okay, so using this way you can generate any signal for your, like your chamber. You want to just control the temperature. If you maybe you just only turn on the fan for your chamber, It is not for heating purpose.
Yes.
You are you just maintaining the temperature for both the conditions, or just need to uh, just remove the heat from that chamber?
No, sir. It is a ramp test. It's a initially increase and then some particular time hold on and then will be reduced and then cycle
Okay.
will be continued.
Mainly it is both the increasing and decreasing both way. So for that purpose, you just need another signal also. One is for AC and another one is for another device that may be heater, because you want to just increase and decrease the temperature. So again, you just need to, let's say right now it is 25 degrees Celsius. You just copy again this one and generate another signal for another pin. Let's say pin number 1. Okay, and over here in that case you just need to put the different condition. Let's say I am just putting over here, I just copy this one, and over here I just, let's say the temperature should be between 20 to 25 degrees Celsius. Let's say it is up to you. You just change this temperature in between also in the running program also. So less than, when this temperature, this initial temperature, this is my input temperature, when this input temperature, let's say it is less than 20 degrees Celsius, in that case it will generate again two signal, and in this case I am just using another pin. So using this you can create your own temperature control method for your chamber. Okay. So this is the example related to the device, that is NI DAC card. I just go through the 8451 or 8451 device. I just show you what, or maybe you also know how many analog pins, how many digital pins it is having. Have you worked on this device?
No, sir. I'm going to work, but still not getting the LabVIEW.
Still not getting the
LabVIEW system, sir.
But
I have only the device only. In the LabVIEW system now they are using for MathCAD. I getting for the next week only.
Okay.
So before that I need to know how to configure the chamber, and Python script also side by side I am doing to configure the AC source and then E load. I try to configure the chamber also, but today I tried, it's not possible. So we are going to move to for the LabVIEW.
Okay. Using LabVIEW you can also code Python programs. In my course I already
yeah, you already told the MathCAD only can. You are saying MathCAD or MathCAD program.
Yes.
MATLAB program only we are trying. Python also can.
Python's program also we can do it with LabVIEW. You just need to let's say any device that is running using Python, you can control using LabVIEW also. Just copy that code. I just show you in the future lectures. Okay. So today I just go with this MyRio. As you see, this is a FPGA board. This is the advanced version of this NI DAC, because there is a problem with these DAC card. These DAC card, there is a problem when you just remove your USB, the program it cannot store any program.
Okay, it will be erased. Yeah.
Okay, but in the case of this MyRio, it will store the program also. Okay. When there is a power, when you remove this power, it requires external power also. When you remove this power, after the removal of this power, the program goes. Till power is there, it will store the program. Okay. So in this case, you just go with the project, not go with the VI.
Project.
Till now, we just go with the only VIs. Right now, I just show you how to go with the project. So I just close this VI. So as the latest software, the MyRio software, it is not available with LabVIEW 2023 version. It is available with, earlier it is available with 2019. Now it is available with 2021 version also. So I just close this VI. As you see over here, I just first connect. In this case, you just need a adapter. I first power it. It is not powered by the 5 volt only. So the 5 volt is the USB is only for the programming purpose. Okay. So as you see over here, I just need to create a project. So as you see over here, we have different devices. So right now I just select MyRio, and over here I just select MyRio project, and now I just click on next. Till now my device is not connected. So as you see, plugged into USB. So when I just connect it, it will show me over here the device. It is searching for device right now. Over here, this is my device. Okay, it has different capabilities like analog input ports, analog output ports, digital input output ports, different buttons, different LEDs, accelerometer, PWM signal you can generate, SPI, I2C, UART, different protocols over there, communication protocols over there. Okay, so right now I just finish it. In the first case, you just need to configure this one. Every time when you just create a project, you just need to deploy your project into this hardware device that is your MyRio. So over here, as you see, this type of window pop-ups, and over here this is my main MyRio. I just open already created VI. This is the main VI. Inside this you can edit it also. Right now it is for accelerometer, that is inside this device. So when I hit on run button, it will deploy the program. Unable to resolve. 1 minute. Maybe some softwares programs are not available. 1 minute. Next. The target is running in the version of LabVIEW that is different from LabVIEW on the host. Maybe there is a issue of LabVIEW 2020-21 version. 1 minute, I just resolve it. Because earlier it is available with 2019 version only. And MyRio is connected. Next. It will take some time.
Okay. So now
Right now I am just formatting its earlier program or configure for the 2020-21 version. As you see, the firmware is updating right now. Earlier it is for, as I already told you, 2019 version. Right now I'm in front of you just first time using again this for 2021 version. So right now it is just updating, and when it is for 2023 version, again there is update for this Rio, my Rio. It is provided by LabVIEW only.
Okay. For every revision change, we need to update again and again, or
For what? If you want to just let's say there is a toolbox that is available in only with the 2023 version. Okay, so for that purpose you just need to update. Otherwise, if you have any hardware that is working with, let's say, 2019 version and you have 2020 version, you just need not to install or upgrade your LabVIEW software. For newer toolbox, you just need to update only.
okay.
Restarting. So over here there are different pins available on this view also. There is a reset pin also. I am just pressing this reset pin. It will reset my Rio. Your system is upgraded or not right now, or it is in upgrading mode?
2023 updated, sir.
Completely.
Yes, sir.
Have you checked for waveform chart, waveform, digital waveform? It is available or
Yes,
not?
sir, it's available.
Okay. It is taking more time. I just configure it again. I need to configure it again, and otherwise it is showing again error and error. Once I just check for it, just want to deploy, let's check what happened. Again same error is there. I need to configure this device again. So in the next lecture we just go with this device. Okay, so
Okay.
for today this one, have you gone through the PPT I shared to you
Yes, I do.
through all the programs?
Not programs, sir, but I verify all the items.
Let's say there are different terms. I just show you. Let's check for level 2. Have you gone through these functions like implies? What is the function of this implies?
Not implies.
You just go through this. Then these are the simple examples and or. Okay, and these again it is for numeric one. When you operate on numeric one, numeric value, numeric integer value, what happened to the these indicators, you just need to check over here. When we just go through the loops, and like over here we have digital signals, you just try only one. Okay, then we have different.
I'll let you know tomorrow, sir, if
Okay.
any questions are related.
Okay, now as you see over here, these are for floating values, and I just show you like over here when what happened to this array and what happened to this array, and like this there is a important question like over here select function is there. What happened to this select function according to these given conditions? Again, as you see over here random number, and this is the important function that is hex digit. As you see over here, you just go through these function also. Okay, you just need to create your own VI and just check the functions performance or function operation. Okay. So this is all about today's lecture, and if you have any problem with these VI, you just message me. Okay.
Yes, sir, sure.